Hey guys, I'm Jed. Welcome back to my LeetCode Review One Take blog on the 210th problem, Course Schedule, 2nd edition. There are a total of 9 courses we have to take, labeled from 0 to 9 courses subtract 1. We are given an array prerequisites, where prerequisites of I equals AI and BI. Indicates that we must take course BI first if we want to take course AI. We need to return the ordering courses we should take to finish all courses. If there are many valid answers, we could return any of them. Or if it is impossible to finish all courses, we can return an empty array. And let's see the example 2 here. We got 4 courses and prerequisites here. To take course 3, we should take both courses 1 and 2 first. And both courses 1 and 2 should be taken after we finish course 0. So one correct course order is 0, 1, 2, 3. Another correct ordering is 0, 2, 1, 3. Now, let's start with the main idea of this problem. When we first solve this problem, we could analyze it as a classic application of topological sorting in directed graph. Here's how we think about it. First, each course is a vertex in a directed graph. Second, each prerequisite AI, BI means there's a directed edge from BI to AI, because course BI must be taken before course AI. Third, our goal is to find a valid order to take all courses, which is essentially asking for a topological sort of this graph. Finally, if there is a cycle in the graph, then it's impossible to complete all courses, and we should return an empty array. And we have 2 approaches. The first approach is called Kine's algorithm. With integrity, counting, and breadth-first search. And the second approach is called depth-first search with cycle detection. Both approaches can solve this problem. And let's start with the Kine's algorithm at first. Inside code, we begin by creating an adjacency list where adjacency list of I contains all courses that we have course I as a prerequisite. So we could declare a variable, and its type is list of integer, called adjacency list. Here's a new empty array list. Then we initialize the adjacency list with empty lists for each course. For integer I, here's 0, starting at 0, when I is less than none courses. We'll increment I after each iteration. For each iteration, we'll add a new empty array list into the adjacency list. Dot id of new array list. Next, we need to create an array to check the integrity for each course. Integer array called integrity. Here's a new integer array of num courses. Then we need to process each prerequisite to build a graph and calculate integrities. We can use a enhanced for loop. Integer array called prerequisite. In prerequisite. For each prerequisite, first, we should to retrieve the course and prerequisite. So integer course gets prerequisite of 0 and integer prerequisite gets prerequisite of 1, and we'll add an age from prerequisite to course in a graph. Adjacency list dot get of prerequisites dot id of course. Then we'll increment the integrity of this course. Integrity of course plus plus. Next, we'll create a queue to perform breadth-first search, starting with all courses that has no prerequisites. Queue of integer called queue gets new linked list. Oops. Then we add all courses with no prerequisites to the queue whose integrity is 0. For integer I starting at 0 when I is less than none courses. We'll increment I after each iteration. Inside the for loop, we'll check if integrity of I equals 0. If so, we add it to the queue. Then we'll create an array to store the topological ordering of courses. Integer array, let's say called result, gets new integer array with none courses. Next, we'll declare a count variable to keep track of how many courses we've processed. Integer count starting at 0. Next, we'll process courses in topological order with a value while not logical symbol with queue dot is empty. Inside value, at first we need to take next course with no prerequisites remaining. Let's say integer count, integer current get queue.poll. Then we add this course to a result array. Result of count plus plus gets current. Then for each course that has this course as a prerequisite, we need to create a for loop, enhanced for loop. Integer next in adjacency list dot get of current. Inside the enhanced for loop, at first we need to reduce its integrity because we have accomplished one of these prerequisites. Integrity of next decrement Then we need to check if all prerequisites for this course are now completed. If so, we need to add it into the queue. So the code is if in degree of next equals 0. If so, we add it into the queue. After processing courses in topological order, if we couldn't process all courses, then there must be a cycle. So we'll check if count is not equal to none courses. If so, we'll return an empty array. Integer array with 0 length. Or we'll return the valid course ordering, return result. Alright, that's all of the code. Let's submit our code and check if our solution passes all test cases. Bravo! Our code got accepted. Now, let's analyze the time and space complexity. Do it later. So for the time complexity, it is big O of V plus E. V is the number of vertices and E is the number of edges. We have processed each vertex and edge exactly one time during the breadth-first search. So the overall time complexity, it is big O of V plus E. And the space complexity, it is also V plus E. Because in this approach, we have stored the adjacency list, in degree array, queue, and the result array. So the overall space complexity, it is also big O of V plus E. And this is the end of my LeetCode Review 1 Take vlog on this problem. And you can also visit my GitHub repository, my online GitHub page here, which contains all the problem description, intuition and idea, solutions with code and comments, and final time and space complexity analysis. You can also visit my GitHub repository here, which contains all the code and notes to build this online GitHub page. And thank you guys for watching. I'll put those two links on my YouTube description below. And see you next time. Bye bye.